everyone. Thank you so much for joining the session. I'm Lakshay Kumar. I'm currently a generative AI engineer at Zoto. I am also founder of Connect AI. Uh, that's the AI community based out of Bangalore, Pune, Hyderabad, Gurgaon, and Noida. I have been a community speaker and given more than 25 plus talks in last 3 years. I've also been a Microsoft Learn Student Ambassador, and I've also authored a book from data to world, 5 real-world secrets for data science. It's available on Amazon, and if you want a free copy, you can drop me a mail. Okay, so for today's session, I'll give it all 30 seconds. Just keep paper and pen ready because you're going to do a lot of math stuff. Everyone, just drop in comments if you are ready with paper and pen. Okay, so got a thumbs up. Okay, ready. Sorry, I am not well, so. Okay, I still only see 4, 3, 4, 5 thumbs up, 6. Can I just see a few more thumbs up? Okay. Okay. So let's just start. So the artificial intelligence. So before just looking at the screen, can just someone explain what is artificial intelligence according to you? Can someone just unmute? And you're like, what? A man-made thinking power. Okay. Any more additions? I think this is going to be an interactive sessions. So please try to interact as much as possible. I do have certain simulations. Robochitty, correct? Yeah, that's a good example. Making machines to learn and think like human, correct. So Google defines artificial, like AI, as artificial intelligence is a field of science concerned with building computers and machines that can reason, learn, act in such a way that would normally require human intelligence or that involves data whose scale exceeds what humans can analyze. So I have just highlighted certain words. Machines can learn, reason, and act. Okay. Now, how do machines can learn? Okay, but before we discuss how machines can learn, you see how humans analyze things, how humans derive patterns. I have this table like age and if that age is allowed to play game or not. Can someone tell me what is the pattern here? Just quickly just look at the data. I have just some ages and some and yes and no labels. Can someone tell me what is the rule behind it? Logic, like why is it 18 plus? Yes, Praneeth, correct. So if you see and analyze, anything that is above 18 have a Y. Anything that is less than 18 have a N. So how do we humans come up with this rule? Praneeth, could you just elaborate like what come to your mind like when I just displayed this data? Why do you think it's about 18 plus? Okay. Say the age and say the Y and N. Correct. So unconsciously, when you're looking at this data, you are unconsciously trying to find a pattern. That's a natural human tendency. Whatever set of sequence of numbers or sequence of data we humans see, we try to find a pattern. And now we have to train a machine that tries to find that pattern. Okay, let's just try a simple simulation. Okay. Now, this is basically the system, there's a number. Okay, and system has and we have to guess that number. Now system, for every guess, you have to enter what could be that number. System will give you feedback. Okay, if you're close to number, you're on right side of the number or you're on the left side of the number. Okay. Okay, let's start. Can anyone tell me a random number? Let's tell me a random number. Okay, let's say 25. Okay, you're getting closer. Move to the, so I have entered number 25. I get the feedback. I am close to the actual number. Move to the right. Okay, what's the next number do I try? Let's try 26. Someone said 26. Okay, move again right. Okay, someone said 35. Okay, yes, correct. We guessed it right. So what is right now happening? Now here in this simulation, we are machine learning. At every point, we are trying to guess the number. And there are certain equations that are giving me feedback. If I'm closer to the number, how close I am to the number, if that number is on the right or the left. This is just a basic core of machine learning, how it actually works. It works on the error. When you first tried, when you were just seeing, okay, you're closer to the number, it's basically kind of feedback to the error. Correct? So, and based on that, we made our next guess. We improved our guess. Do you want to try the simulation once again with a medium level number? Audience? We'll try again with this medium level number. Okay, let's try. Okay, machine has generated a random number. Try to guess what that number is. Okay, let's start. Any guesses I should put in? 200. Okay, you're far away. Move to the left. 145. Okay, still quite far. Move to the left. 220. How? It asked me to move left, which means we cannot cross 200. Okay, 120. You're still quite far. Move to the left. Remember, we are still quite far. Okay, 94. Your neighborhood. Move to the left. 54. Okay, 86. Move to the left again. See, okay, let's not do a guesswork. Let's just be a little smart. It says you are in neighborhood, which is we are near to that number. We have to move left. What is the last number I used? 86. Is I have to move left of the 86, which means that number has to be lesser than 86, but not too less. Okay, someone said I think 40 is too less. Okay, let's try 85. Someone said 85. Okay, move to the left again. Any more number? 60. Okay, 60 seems fair. Okay, again, I have to move left. Remember, move left, which means whichever number I'm entering, I have to enter lesser than that number. Okay, 40. We're moving closer. We are getting closer to that number. Someone said 45. No, because 45 is again or greater than 40. And it's on the right side. We have to move left. 30. Someone said 30. Okay, again, I have to move closer to the number. 20. Very close. Move left. 15. Again, very close. Move left. It says left. So, okay. Oh, so many numbers. Let's try 12. Oh, 10. 9. Oh, someone said 7. Extremely close. Any more guesses? 6. 5. 4. 3. Correct. So in 20 attempts, remember we have to take 20 guesses to reach at the correct number. Did you understand what is happening? Did you all understand the feedback mechanism and how we use our next guess? Can I see some yes or no? Okay, yes. Any no's? Okay, it looks like okay, we understood it. Okay, let's go back to the slides. Okay, so we just know how machine learning works. It's guiding us through feedback, correct? So whatever input we are giving, The machine is telling us the feedback. Okay, but when we are programming or building a machine learning model, it actually it happens actually the opposite. The machine takes the feedback with the number that it predicted versus the actual number. Now, okay, let's hold on for here about machine learning. Let's see how it is different from traditional programming. So what happens in traditional programming? I have let me just take some Slate's point. Okay, I have an input and I have a rule. I feed input and the rule to a function and I get the output. For example, I have input as 20. I have rule that input has to be divided by 10. So I get the output 2. Is this clear? Input, rule, and output. Okay, next. Now what happens in machine learning? In machine learning, I have old set of input and I have old set of output. I give old set of input and output to a function and it generates a rule. Okay, basically I swap the position of rule and the output in the traditional programming. When I get this rule, I feed this rule along with an old or new input and I get the output. So if we see this example, so I have old set of inputs, I have old set of outputs. I process it and I get the rule that f of x will be no if age is less than 18, otherwise it will be yes. Now for new age 23, I put this new age into this function. According to this function, this should be y, and I get my output y. This is the flow of machine learning. Okay. Now this f of x is the function that machine learning will predict. We give it input and we give it output, and this f of x is what machine learning will predict. Our model will predict. Okay. Now this is actually the basic core of machine learning. This is a plus minus error because whatever prediction machine learning do, it is never 100% accurate. There's always some factor of error. No machine learning model is always 100% accurate. So we introduce this plus minus e term. Okay. So machine learning is divided into 3 parts. Supervised, when I know what is my input, what is my output. And this is most widely used field of machine learning, supervised ML. Then we have unsupervised ML, where I only have the inputs, no outputs. So what we try to predict the patterns in my inputs itself. Now then I have reinforced machine learning, where they don't have input or output. It just model learns in an environment like through a feedback. And supervised machine learning is the most widely used machine learning. Okay, so this is a definition of supervised machine learning. Machine learns to make predictions on labeled data. By labeled data, I mean I know what is my input and what is my output. Okay, it predicts a set of outputs for the given set of inputs x with some error plus minus e. So in short, this translates to machine will predict a function f of x for the given set of inputs. It will predict the function f of x that predicts the value y that is closer to that with an error factor that predicts a value y with an error factor e. So in short, when I give my x and y to the machine learning model, it will predict f of x, but with some error, and this error has to be a minimum error. Is this clear to everyone? Can I see some thumbs up? Can I see some thumbs up in the chat? Okay, I see there's a question. Yes, Mukesh, you have a question? Mukesh, I see your hands up.
There is no question.
Okay, so, and this again is y is equal to f of x plus minus e. Now we have different algorithms, different methods to find this f of x. Today we'll be seeing one regression and one classification algorithm in detail. Okay, and then this error e, this comes from existing set of x and y. Okay, that I'll explain you in the later slides how this e is predicted. Okay, let's first see regression. Okay, so regression we have two types of regression. One is linear regression and one is multiple regression. I'll be explaining linear regression in detail in this session. So linear regression is a statistical method used to model relationship between a dependent variable and one or more independent variable. So basically what linear regression do is it tries to model a relationship between an independent variable, that is my x, and my dependent variable y. My y is dependent on x. If you see first, I see that my x and y are increasing. For example, your study hours versus marks. Imagine on your x-axis, I plot your number of hours you studied for the exam, and y-axis, I plotted your marks scored in the exam. So they both will increase as your study hours increase. That's a general trend we'll see. So that's an example of positive linear regression. Now, when I have negative linear regression, what happens there? When my x, so y will decrease as x is increasing. For example, demand and price. If my demand is increasing, so sorry, if my demand is decreasing, price will increase, correct? So that's an example of negative linear regression. When my x increases, but y will decrease. And now when I have no relationship between x and y, that is just some random dots, plots on the graph. These are three types of regression lines. So let's see this function. I have R studied on x-axis and marks scored on y-axis. So what my machine learning model has to predict a function in which I enter my R studied and I get my marks scored as an output. Okay, but with a error plus minus e. Now, if I see the general trend, if I just try to plot a line, a general rough line, this is what my approx line will be. This line is my approx line that shows relationship between my R studied versus marks scored. And this line is my regression line. So the line is calculated using machine learning. Let's see how it's actually calculated. So have you all seen this equation y is equal to mx in your class 10th? We all seen this equation y is equal to mx. What is m here? You don't tell me what is m here. The f of x is basically my this entire function mx. Yes, my m is a slope here. So that defines the inclination, how much inclined my line is. For example, if I plot a line like this, and even this, I see this line is more inclined and this is less inclined. It have lesser inclination, lesser slope, and this have minimum slope. So m is my slope. This basically determines from the origin how much slope is there. Okay, and then we have c. In real life case, that can rarely I will find that my regression line is starting from 0. It can start from plus 10, it can start from plus 20, it can start from any number. But there are rare cases when it starts from 0. Even it has to start from 0, it would be c would be 0. Okay, so my m is basically the inclination for this line, and c is the distance from the origin and the point at which my regression line cuts the y-intercept. Is this statement clear? C is the distance between my origin and the point at which my regression line cuts the y-intercept. Is this line clear? Can see some thumbs up? Okay. And there can be case when my slope C is negative. In this case, even my m is negative because slope is in the negative direction. Okay, negative is nothing, it's just a direction, right? If I say in the number line, this is 0, this is 5, and this is -5. So my magnitude is same, it's just the distance, right? So it's just the direction. My magnitude is same. Okay. Now let's find out for this given set of data. This is my data. For example, if I study 3 hours, I get 67%. If I study 4 hours, I get 72%. I study 4.5 hours, I get 70%. I study 5 hours, 77, and so on. Now let's try to predict. Let's try to find how much marks a student can get when he studies for 12 hours. Okay. Is on. I just need place a pointer. Okay. Now let's do some mathematical calculation. If I just plot this on the graph, I see there's a linear relationship between them. You all agree? There's a linear relationship between my hours studied and marks. You all agree? Okay. Now let's try to find a line that is at the least distance at the least distance. By least distance, I mean with the minimum error that tries to predict the marks when I study for 12 hours. Okay. Now first, let's just see how M and C works. Here is the sample data. I have this graph. Okay. Now what if I put any value of M? 2, 3. Can someone explain what is happening when I'm changing the value of M? Can someone explain? 92. What exactly is happening when I am changing the value of M? Screen is not clear. Okay. Can you see my screen now? Is it clear? Is it clear
Yes,
now?
perfectly clear.
Okay. Now what is happening when I'm changing the value of M? Line is changing. Yeah, line is changing, but what exactly is changing in the line? Slope. Okay. Slope is a mathematical term, but what observation do you see? Slope is increasing, but what is the observation? You see, its origin is remaining same. It's just inclination. Line is going upper left. Correct. Line is going upper left. That means its inclination is changing. As I am changing the slope, as I'm increasing the slope, as I'm increasing the slope, the inclination is increasing. Correct. Now let's see the effect of C. I put C 10. What is happening? With C is equal to 10, what is happening? What is happening when C, when I'm changing the value of C? Okay, for M, we get, as M increasing, it's getting more steeper. And what is happening when I'm changing C? C increase line moving up towards higher Y, correct. So it's basically when I'm changing C, this is changing the vertical position on the graph. Correct. See, this is changing the vertical position. 16. Okay. Now let me open a regression simulator. Okay. Let me just zoom out and then I'll zoom in a little bit. Okay. So this is the data that I just showed you on the slides. This is the data that I just shown you on slides. This is my M that is coming from here. This is my M into X when my M is multiplied with my R studied. C is what I'm entering manually here. We'll experiment with different values of M and C and see when we get the least error. And then I have Y, basically just add these two values and this error. This error basically difference between this predicted marks and the actual marks. Now, let's start off. When my M is 0, I have error 6331. Let me try putting 1, 1 for both. I have lesser error. And what's the next number you like to suggest for M and C? Any comments? What is the next value for M and C you'd like to suggest? Okay, someone said 5. 5 and 5. Okay, my error still decreased, but still, see the difference between this line, these dots, and actual dots. Still, I have high error. But next number I'd like to suggest. Definitely, yeah, I will definitely share these sheets after the session. Someone said -3. Let's try -3. Okay, I have very high error now. 15, let's try 15. I see lesser error, but again, still, if you see here, I still have high distance between actual and predicted. 50, okay. It increased to 86,000. Okay, let me just explain what this 86,000 is. This is basically difference. When you take difference of these two, you get either a positive number or a negative number. Okay, but when you have negative number and when you add it to positive, your magnitude decreases. Your magnitude decreases. So what we are doing, we just take the magnitude, square them, sum them up, and then take a square root. I'll show you equation in the coming slides. Okay, now let's come back to this error. Can you see this graph, the second graph? You see the second graph? Now in this graph is basically number of steps and my error. We started with less error and then suddenly my error shooted up at the 5th step. Why at the 5th step we entered 50? Lost you some here. Okay. Okay, so let's just come back here. So 15. When I have 15, let me just clear these and start again. So I see my error is decreasing with number of steps I'm taking. Let's try for next value 6 and 6. Again, I'm going well because my error is decreasing. My target is to reach at a step when my error is lowest. And that too in the least step. This is the hard work that machine has to do. For us, it's just one step, but machine takes multiple points, like thousands of points between 0 and 1. It also calculates the decimal values. Let's try with 7. Okay, I am on right track because my error is decreasing. Let's try with value 8. Again, I'm going on correct track. 9, lesser error. 10, again less error. 11. Now my error is increasing. You see, in 8 steps, I have reached to the lowest error. Now, if I start increasing from here, my error will increase, and I don't want that. So this is the point of my lowest error. If we compare the predicted marks and the actual marks, we still see that there is a significant number of errors. This is 67, this is 44, this is 72, this is 55. This is predicted as 70, this is predicted as 60.5. This is becoming 70 and 66. So I still see like there's a significant number of errors. And I can see from this graph that there's only one point that is closer, other I do have a lot of error. This is happening because we are not taking the optimum value. Machine use an algorithm called gradient descent that calculates the optimum value of M and C at every step. And they are not taking like 8 steps, they take thousands of steps. Okay, let's come back to the slides. Okay, we just saw how MNC works and how do we find the best fit with MNC. Now, how machine? Now, once we have found out the MNC, there is the factor of error. And this is very important in machine learning, with what error your machine learning is predicting. Now imagine I have this red line as a regression line. This regression line, I have a point on above this regression line and I have a point below this regression line. Let's say this is at units A, at A units distance. This is in the opposite direction, so negative. And if we are just summing up, I get 0 error. That is not true in this actual case. So what we usually do, we take individual sum of squares, take their average and then sum up. Individual distances, we are just adding, taking the average and taking the square root. And then we get the average error. This is called root mean squared error. This is similar formula. This yi is my actual value minus predicted value. I'm taking a whole square, summing them up, and then I'm taking the average. And finally taking the root. This is called root mean squared error. So basically a metric through which I find the error of my regression model. Just like RMSE, we have so many other error metrics in machine learning. Now, next is logistic regression. We just saw why should we take square root? Because we are individually squaring them up. Is it clear? Because we are taking a square, just to bring back that square, we are taking the root at the end. Is it clear? Unknown. Okay. Now logistic regression. It's again a supervised machine learning algorithm through which I can do binary classification. So in a binary classification, when my output is either yes or no. Okay, which means machine learning will have to find a function that will on the same data. Machine learning has to find a function that will predict if for the given age if the person is allowed to play game or not. Yes or no. Since machines can't understand text, we are using 0 for no and 1 for yes. And let's just plot those on my graph. So I see below 18, I have all the no's, and above 18, I have all the yes. Say above 17. So machine learning has to find a function that will tell me for the given age. For the given age, if a person is allowed to play a game or not. So if I see, this is the approx, we cannot make a line. We have to make a curve, because if you see this is like this. So we cannot make a line. So we are making a S-shaped graph here, because line is not possible. So for example, if I just plot this line or this line, my model will not work. I will have a very high error because it's either at 0 or at 1. Now, can this graph, can I just find a mid benchmark that above it would be, sorry, the label should be scrapped. That's an error in the slides. Above this graph, this should be yes. And above this, below this, this should be no. We can create this S-shaped graph and create a benchmark. Okay. Now, this entire creating graph, finding benchmark, this machine has to do. But we just have to feed it this data. So what equation machine learning uses? So machine learning uses this equation. So this is 1 by 1 plus e to the power, if you see, mx plus e. This we just saw from a regression. So my machine learning, my machine learning was using mx plus c to calculate the perfect fit. Here my machine learning is using this equation with same m and c to find the S-shaped curve. Now, the output of this value will always be in range from 0 to 1. For example, if machine learning output 0.7, so I can say that 0.7 is greater than 0.5. Machine learning is greater than 0.5, then it's a yes. If someone requested, I should explain again. Definitely. It is all. Okay. When I had regression, when I was about to when I have to predict a discrete value like continuous value, for example, for 12 hours it should be 97%, 11 hours 95%. I am not sure of my outputs, right? That can be any discrete value. Now, but in this case, I know my output. It can either be yes or no. So yes, I am denoting by 1, and y I am denoting by 0. So if I just plot that on the graph, all my no's and all my yes, there's a correction. This should be y and this should be n. Now, if I'm allowed to play or no. Now, a regression line will not help me in this case because regression basically predicts the continuous value. For example, for the 97%, for 11 hours, it's 97%. For 10 hours, it's 80% marks. So we are not really sure of the outputs. But here we know that my output is a classification. I know my output can either be yes or my output can be no. So for this, we are plotting my points, and instead of drawing a line, we draw a curve. And this curve, machine learning creates a differentiation that above this, any value above this would be a yes, any value below this will be a no. So how machine learning makes this curve? It uses this function. In the previous case, we were using y is equal to mx plus c. Now here it's just using exponent terms. So my values are always between 0 and 1. For example, now my value came after my model is trained and after my model predicted the value of y and c, my output of the function came out to be 0.7. This 0.7 is greater than my threshold, that is 0.5. So it will result in yes, because this is greater than my threshold. This is my threshold, 0.7 is greater. It comes in this range. So it will respond with yes. Otherwise, if it is 0.3 for say, this is less than my 0.5. So it will respond with no. Okay. Now, how do you find error for logistic regression? My error is basically if my output is equal to if my predicted value is equal to my actual value or not. Now, let's say we have let's say we have built a machine learning model, and machine learning model predicts this. For age 10, this is correct. And it predicted minimum age to be 17. And for 17 age, it responded with yes. So this is the incorrect prediction. So how do we find error? My correct predictions are 6 out of 7. That is 85.7%. This is the simplest way to find error in logistic regression. But we do have a lot of more sophisticated, more robust methods to find exact error for large data sets. This is the most simplest one. Now, what next? For machine learning algorithm, we just saw two algorithms: logistic regression and linear regression. Similarly, we have a lot of algorithms that I'll be sharing resources in this slides. So two important things. One is which algorithm you are using and the error. These two are the most important parts for a machine learning model. How you're predicting and with what error you are predicting. So if you see this, I have so many machine learning models: linear regression, logistic, ridge, lasso, then I have decision tree, random forest, and gradient descent. I've given link in this slide. You can read about these algorithms. This I have sourced from DataCamp. You can read about these algorithms and understand the maths behind them. I have explained the two simple algorithms in these slides. And if you want to learn beyond this, then there's a course that I'll highly recommend by Deep Learning. It's on Coursera. You can view this course for free. It's very professional. They have details and hands-on learning in this session. This then on this YouTube, there's code basics. They use practical applications, and it's one of my favorite YouTuber for machine learning topics. Then there's 3 blue and 1 brown. They explain all the machine learning concept with a very nice visualization. I highly recommend this. Once you've done all these on the Kaggle, you can search for data sets and start practicing your machine learning modeling. Okay. At this point, any questions from the audience? Do you have any questions?
Yes, they will share the questions in the chat box. Share the questions, students.
Okay. Meanwhile, if you have any questions, I have a free meeting link. You can book a meeting here. You can connect me over social media, LinkedIn, Instagram. These are my links. And this slide you will get at my resources. So all 3 links I've given, you can take a screenshot. So I'm up for any questions if you all have any.